On March 30, 2026, Guangdong Province experienced a prolonged and highly disruptive severe weather event as an intense convective storm system swept across the region. It brought torrential rainfall, continuous thunderstorms, and powerful wind gusts that caused widespread disruption to daily life, infrastructure, and transportation network. Across cities such as Guangzhou, Qingyuan, Shaoguan, Shenzhen, and Dongguan, rainfall intensified quickly. In several locations, heavy rain transitioned into torrential downpours within minutes. Localized totals exceeded 100 millimeters in just a few hours, overwhelming urban drainage systems and leading to rapid surface water accumulation. In Guangzhou, the arrival of the storm was marked by a rapid and dramatic shift in weather conditions. The sky darkened as thick storm clouds spread across the city, blocking sunlight and creating an atmosphere resembling nighttime during the early hours of the day. Thunder echoed continuously, and lightning flashes illuminated the skyline as heavy rain fell with sustained intensity. As rainfall continued, water began to accumulate on major roads, particularly in low-lying districts and underpasses where drainage systems struggled to keep up with the volume of water. Traffic congestion quickly spread across key routes, affecting both private vehicles and public transportation. Pedestrian movement was also impacted. Sidewalks became waterlogged, and strong winds made it difficult for people to move safely outdoors. Many residents sought shelter in nearby buildings, waiting for conditions to improve. While the heavy rainfall created immediate challenges, the wind conditions added a more dangerous dimension to the storm. Wind speeds across Guangdong rose steadily as the storm intensified. Gusts of force 10 to 12 were recorded in many areas, while some locations experienced peaks approaching force 14. These winds were strong enough to cause structural damage and significantly increase the risk of falling objects. Shenzhen and Dongguan experienced some of the most intense wind impact. In these cities, the combination of dense urban environments and strong wind flow created powerful gusts at street level. Large trees lining roads and residential areas were unable to withstand the force. Many were uprooted or snapped, falling across roads and onto parked vehicles. In multiple incidents, fallen trees landed directly on cars, crushing roofs and breaking windows. Some vehicles were left severely damaged, while others were completely immobilized beneath debris. In addition to fallen trees, billboards and roadside signs were torn loose or destroyed by the wind. Temporary structures, including construction barriers, metal fencing, and small shelters, were blown over or displaced. Loose materials were carried by the wind and scattered across streets, increasing the risk of injury and further complicating traffic conditions. Buildings also experienced varying degrees of damage. Reports indicated broken windows, dislodged exterior panels, and minor structural impacts in some areas. Debris falling from height created additional hazards for pedestrians and vehicles below. The combined effects of rain and wind placed sustained pressure on urban infrastructure systems. Drainage networks were pushed beyond capacity in certain locations, leading to water accumulation that persisted even after rainfall intensity began to decrease. Power fluctuations were reported in some districts, likely linked to weather-related impacts on electrical systems. Emergency response operations were activated across multiple cities. Local authorities deployed crews to remove fallen trees, secure unstable structures, and manage traffic flow in affected areas. Coordination between emergency services, municipal departments, and transportation agencies was essential in maintaining public safety during the peak of the storm. Public warnings were issued repeatedly throughout the day. Residents were advised to remain indoors where possible, avoid travel unless necessary, and stay clear of construction zones, roadside trees, and damaged structures. Transportation systems across the region were significantly affected. Road congestion increased due to flooding and debris, while some routes had to be temporarily closed. Public transport services experienced delays, and airport operations were disrupted, with flights delayed or adjusted due to adverse weather conditions. From a scientific perspective, meteorologists highlighted that the storm was driven by strong thermal and moisture contrasts within the atmosphere. The influx of warm, moist air provided energy for storm development, while the incoming cold air enhanced instability and vertical motion. This combination allowed storm clouds to grow rapidly and produce intense rainfall and strong winds over a short duration. Such convective events are typical during seasonal transitions, but the intensity and frequency of high-impact weather episodes have raised concerns among experts. Rapid urbanization further increases vulnerability, as dense infrastructure and large populations amplify the consequences of sudden weather extremes. As the storm system gradually moved eastward, rainfall intensity began to decrease in some western areas. However, unstable atmospheric conditions remained in place, and additional storm development continued to be possible over the next 48 hours. Even after the most intense phase had passed, lingering risks remained. And loose debris posed ongoing hazards. Standing water in low-lying areas required time to drain, prolonging the impact on transportation and daily activities. Residents were encouraged to remain alert and continue monitoring official weather updates. Authorities emphasized the importance of caution even after visible weather conditions improved, as secondary hazards could still develop. The events of Monday demonstrated how quickly severe weather can escalate and affect large urban regions. The combination of heavy rainfall, destructive winds, and rapid onset created a complex emergency situation that required coordinated response and public awareness.